Hello everyone, what I am going to talk about today is our paper entitled Using Spark Distributed Deep Learning to Analyze NetFlow in Data Lake System. My objective today is to present a framework for storing and analyzing weblog data based on the concept of data lakes. First, I will talk about the introduction. Then, I will look at the background review and related works. Next, I will discuss about system design and implementation. Following, the experimental results, and finally summarize the paper in conclusion. Let me begin by explaining about the network security. According to a security report published by NetFlow, in 2019, a total of 8.4 million distributed denial of service or DOS were detected, equivalent to 16 occurrences per minute. As the number of cyber attack incidents has increased year by year, the attack methods have become more and more diversified. How to prepare the system architecture that automatically analyze whether there is an attack in the NetFlow log under big data has become a very important concern. In the current state of artificial intelligence development, a large amount of training data and computing power are extremely important. The concept of data lakes and parallel computing are also important in the future development direction. This paper uses the Cloudera platform to run Spark on the resource scheduling platform Yarn for distributed deep learning purpose. It provides relevant experience and practical data for a high-performance distributed deep learning system. The specific goals are as follows. First, use Cloudera to build a data lake. The system can access a large amount of real-time data, and the files are in various formats such as text, pictures and videos. Second, use Kafka to collect streaming data and store in base. Third, use Spark for the data pre-processing, and cut the dataset of the model training process by cross-validation. Before we conduct the research, we confirm several theoretical methods and the related works, including data lake, Spark deep learning, and other related works. The concept of a data lake first appeared in the article Big Data Requires a Big, New Architecture in the 2011 Forbes magazine. The biggest difference from the data warehouse is that data lake holds a large amount of raw data in its original format until the data is being analyzed and used. Spark is a parallel computing framework developed by Algorithms Machines and People Lab, which focuses on SQL query, stream processing, machine learning, and deep learning. Also, it runs on Java, Python, Scala, and R and other languages. In the past research, the use of the Spark framework to train data accounted for very few studies. Although several scholars also use Spark to analyze NetFlow, but mostly for machine learning methods. We also examined several papers that related to our research. Hongwu Liu et al. Proposed a detection method for instant port-to-port, using PLCNN, a convolutional neural network-based payload classification method, and PLRNN, neural network-based payload classification method, performs attack detection. The two methods learn feature representation from the original payload without feature engineering and support end-to-end detection. Daigusen and Terzi et al. Proposed a new unsupervised anomaly detection method. Its purpose is to determine the anomaly caused by a UDP flood attack on a specific IP. This approach is implemented on public NetFlow data in case studies. Rick Hofstede et al. Explain all phases of NetFlow's traffic output and typical traffic monitoring settings, covering the full range from packet capture to data analysis. This picture is the hardware architecture diagram. The data sources from multiple network switches. NetFlow data is accumulated into the Cloudera cluster through the NetFlow collector. Each node in the cluster is in 1 GB Ethernet connection. Intel Core i7 4770 CPU, 16 GB memory and 1 TB hard disk storage space. Related to the software architecture, this system is built on the Cloudera Big Data platform. The operating systems are all running 64-bit Windows 7. Real-time data is written to base by means of Kafka using Spark streaming. The old system data is manually imported into Base from MySQL using Scoop. The data query part uses Base to integrate Hive and Impala as search engines. The collected data will be identified by the Train Deep Learning module and then stored in MySQL to facilitate Grafana for visualization purpose. The MySQL database setup here only stores the latest real-time data. The intention is to improve the query speed of real-time data visualization. Talking about data. The data collected in this paper is a campus wired network. The average data volume is about 100,000, 16 megabyte, per minute. The number of data in a day is more than 100 million. There are 3 ways to write data. Real-time data, use Kafka to collect real-time streaming data. Historical data, use Scoop to import from related database. Exception, use import TSV to import text files. Confusion matrix. Let's now turn to data storage. This system uses Hive and Base based on HDFS as the storage database. The data is mainly stored in Base, because Base has the characteristics of high transmission and low latency, which is very suitable for reading and writing operations of big data. Hive responsible for converting SQL syntax to MapReduce jobs to search the data on HDFS, this usually used for offline big data queries. This section introduces the system environment used in this paper. A total of 5 physical machines are used to build the data lake, which are a name node, 3 data nodes, and a secondary name node. Move to the experimental results. First, we introduce our hardware experiment environment. A total of 8 hosts are used in this experiment, and the data lake is composed of 5 hosts. Ideally, an independent Kafka cluster should be built. Because of resource constraints, this experiment builds Kafka cluster with NetFlow collector and the data lake. Detailed equipment is shown in this table. Grafana provides usage information of each machine's CPU, network, and hard disk. The chart allows the cluster administrator to quickly grasp the status of the cluster without having to query the working status separately through commands or the background of each service. This figure is the cluster CPU status, HDFS read and write, hard disk read and write, and network traffic visualization in sequence. I'd like to conclude by: first, in this study, we used Cloudera to build a data lake system, which is a completely open-source management platform. It can be easily built by Cloudera users. Second, the system supports the collection, storage, and query of large amounts of data. Also, it provides a series of functions such as analysis, distributed neural network training and visualization. Third, Grafana is used to visualize the data, draw a variety of cluster environments and network usage behavior charts, and provide network managers with a real-time monitoring platform. That brings me to the end of my presentation. Thank you for listening, your attention.